Today I am going to explain about superposition theorem and problems based on that. What is this superposition theorem says? The superposition theorem states that in any linear network containing two or more sources, the linear network containing two or more sources, the response in any element is equal to algebraic sum of responses caused by individual sources acting alone, while other sources are non-operative. Once again, I am repeating, superposition theorem states that any linear network containing two or more sources, number of sources, okay, that is a basic point. So, network having two or more sources, then the response in any element is equal to algebraic sum of responses caused by individual sources acting alone, while other sources are non-operative. The other sources are non-operative, that is, while considering the effect of individual source, the other sources, voltage source is replaced by short circuit and current source replaced with open circuit. Okay, once again, I am repeating, while considering the effect of individual source, the other voltage source is replaced with short circuit and current source replaced with open circuit across its terminals. So that is a superposition theorem statement. Then one point is the superposition theorem is only applicable, it is only valid for linear systems. So this theorem is we can apply only to linear circuits. Okay, solving a problem. For the given network below, find the current in 2.2 kilo ohm resistor using superposition theorem. So we can see the circuit here. So here the circuit has a given circuit containing two voltage sources, 5 and 7, 5 volt and 7 volt, and the elements are this is 1k this side and 2.2 kilo ohm resistor here. So question problem is given that in this network, find the current in this 2.2k resistor using superposition theorem. So we know that what is the superposition theorem? According to the superposition theorem, the response in any element is equal to algebraic sum of responses caused by individual sources acting alone. Okay, so first what we do is take the given circuit as it is, circuit having multiple sources, and find the response in the 2.2 kilo ohm resistor. Take the given circuit as it is, and find the response. Okay, that means with multiple sources, we find the response. That means here with the 5 volt and 7 volt sources are in operation, find the current in the 2.2 kilo ohm resistor. So that is a first thing. Then we consider individual sources. We consider the individual sources operation while other sources non-operative. Okay, that means we consider only 5 volts in circuit in operation, then 7 volt source we replace with the internal resistance, that means short circuit. We replace the 7 volt source with a short circuit and we find the current in the 2.2 kilo ohm resistor. Then next is we replace this 5 volt voltage source with a short circuit and consider only 7 volts source in the circuit. Find the current in the 2.2 kilo ohm resistor. Then the sum of these two currents when individual sources are in operation, the sum of these two currents should be equal to the when all sources are in operation. What the current that what when all sources are in operation, the current in the 2.2 kilo ohm resistor. So that is how we are going to verify the superposition theorem for the given circuit. So first step, consider consider all sources in operation. That means here we have only two sources, 5 and 7 volt sources. So this is the circuit, taking the given circuit as it is. Okay. And finding the response in the 2.2 kilo ohm resistor. Okay. So here see that current in the 2.2 kilo ohm resistor is, let us say that current, take the current is I, capital I. Then how to find the current, this current capital I. So we use our basic knowledge, that means any circuit concept to find the current, this current I. So we may use, one thing is we may use nodal analysis or we may use mesh analysis. So here I'm going with mesh analysis to find the current capital I. That means current in this 2.2K. So see that here applying mesh analysis. So we know that how to apply the mesh analysis. Find the number of meshes available in the given circuit. Number of meshes available in the given circuit, accordingly take the mesh currents. Okay. And then we write the KVL equation in each mesh and we solve those equations to find those mesh currents. So here two meshes we see. Okay, mesh 1, first mesh 1. Okay, this is the mesh 1. I have taken current in the mesh 1 is I dash, and in the second mesh current is I double dash. So taken, those two are the mesh currents. Okay, so see that accordingly, according to mesh analysis, so by KVL in mesh 1. So KVL in mesh 1. So see that what is this become? So all resistors are in kilo ohm. So I'm taking I write only 1 into I dash minus 2.2 into I dash minus I double dash plus 5 equal to 0. Okay, so that is by applying KVL. So from here I started. So the voltage drop in 1K is 1 resistance value into current 1K into I dash, and next element 2.2K current is given by both I dash and I double dash, both are in opposite direction. So it becomes I dash minus I double dash. So I'm going along with the voltage drop direction. So it becomes minus 2.2. Within brackets, current is given by I dash minus I double dash. Okay. Next, plus 5 equal to 0. So simplify and say that equation 1. So minus 3.2 I dash plus 2.2 I double dash equal to minus 5 say that equation 1. Then apply KVL in mesh 2. So I start I double dash from here. So minus 1 into I double dash. Next, the element is voltage source minus 7. Next, current in the 2 point voltage drop in the current is taken already. We have taken I dash minus I double dash, and voltage drop direction is like this. So here it becomes the voltage drop for the second mesh plus 2.2, because I double dash direction is opposite to the voltage drop direction. So that's why it becomes plus 2.2 I dash minus I double dash equal to 0, and this becomes simplified equation, becomes equation number 2. So solving these equations, the I dash and I double dash values are calculated. So those are shown here. The values of I dash is given by 0.11 milliampere, and I double dash is given by minus 2.1 milliampere. Okay, so those are the values for I dash and I double dash. Now if you see I double dash value, that is minus value, means the direction we have taken, the direction we have assumed for I double dash is opposite to the actual direction. So that is the meaning of this negative sign here. So that's why the direction with the actual direction, it is shown with the dotted line here. So I double dash direction is now like this, that is shown with the dotted line. Now coming to our point, what we want to get this capital I. We want to know the value of this I, response in the 2.2 kilo ohm resistor, current in the 2.2 kilo ohm resistor. So this capital I is given by in terms of I dash and I double dash. See how they are related, how this I is related, capital I is related to I dash and I double dash. So if we see I direction is like this. So capital I is given by, in terms of these two, okay, I dash plus I double dash. Okay, so I dash is like this, going like this in 2.2k, and I double dash also going from up to down only. Okay, so that's why in terms of these two, I dash and I double dash, capital I is given by sum of those two, sum of these two currents. Okay, so that's why it is given I dash plus I double dash. So 0.11 plus 2.1, 0.11 plus 2.1, so which is given by 2.21 milliamperes, 2.21 milliamperes, which is a response in the 2.2k when all sources are in operation. When all sources are in operation. Now find the response, that is current in 2.2k when individual sources are in operation. So now we see that when individual sources are in operation. So first consider 5 volt source. First considering 5 volt source alone. So see that the circuit, okay, 5 volt source with 5 volt source with the elements, okay, given circuit element as it is. Only we replace the 7 volt source, the other source, voltage source, with a short circuit. So that is you can see in the circuit. Okay, so now how to find the response in this 2.2 kilo ohm? How to find the current in this 2.2 kilo ohm? Okay, let us say that is I1. So one source we are considered that is in operation, say that, and at the time current is response is I1. Okay, now how to find this I1? So here again we need our basic circuit analysis knowledge, our circuit knowledge, how to solve this circuit to find this current I1. Okay, so here see that one simple method I have taken here. You can solve this, find this current I1 same again by using mesh analysis or nodal analysis. Okay, but I'm going with other technique to find this current I1. What I have done is I have found the current, total current coming from the source, which is taken as IT, total current, capital I T. So that capital IT is given by supply voltage 5 volts, total supply voltage over total resistance of the circuit, which is given by here. So that is a total current. How can I the way I can find? So the 5 by RT. So here RT is given by the total resistance available across this supply. So how to find here? I start from the other side, opposite side. So RT is given by 1, first one and this 1K and 2.2K are in parallel. The resultant of these two will be in series with the 1K. Okay, this 1 and 2.2 are in parallel. The resultant of these two will be in series with the 1K. So that is what I have shown here. So RT is 1 plus parallel combination of 1 and 2.2. Okay, so finally IT value which gives us 2.963 milliamperes. 2.960 milliamperes. Next is my final intention is I want to find current in 2.2K. So by knowing this total current IT, so by using current division rule, I can find this I1. So we know that according to the current division rule, I1 is given by total current into opposite resistance by total resistance. So up to here total current. Okay, so after this is divided among these two elements. So to find the current in one particular element, as I already previously explained in previous lectures, so according to current division rule, that is given by current in a particular element is given by total current into multiplied with opposite element by opposite resistance by total resistance. So here I have 1K and 2.2K. So I wanted to know current in 2.2K. So that's why IT into what is opposite element? Opposite is 1K. So 1 by 1 plus 2.2. So finally after substitution, it gives the value of I1 0.926 milliamperes. 0.926 milliamperes. Next, second step. That means now consider only 7 volt source. Only 7 volt source in operation, and replace the 5 volt source with a internal resistance. That means the other source we have is 5 volt source, which is replaced with the short circuit here. Okay, now so here in this case current in the 2.2K, let us say that I2 current is now with second source, say that current is I2. Okay, now how to find this current I2 response in the 2.2 kilo ohm resistor? So again we require basic circuit analysis. I mean the circuit, how to analyze the circuit to find the current I2. So we may use mesh analysis again or nodal analysis, but I'm going with the like previous case. I find the total current. I'm finding the total current here. Find that is coming from the supply. So I have denoted the total current is IT dash. Here I have denoted the total current is IT dash, which is given by, okay, so supply voltage 7 over total resistance here. Total resistance here. Then let us denote that RT dash. So 7 by, what is how to find this resistance, total resistance here. So you start looking, you start reduce the circuit from opposite side. So if I start to reduce the circuit from the opposite side, 1K, this one and this 1K and 2.2K are in parallel, then the resultant of these two, the equivalent of these two will be in series with the 1K. So that is what substituted. So finally IT dash value is given by 4.148 milliamperes. 4.148 milliamperes. Now after this, finally after this IT dash, finally we want to know I2, current in the 2.2. So again apply current division rule. Okay, so that is given by I2 is equal to total current IT dash into opposite resistance, means here 1, right? So we have the two elements are 1K and 2.2K. I want current in 2.2K. So that's why opposite element means 1. 1 by 2.2 plus 1. Sum of the two resistances. So which gives the total, the current I2 value is 1.296 milliamperes. So this is a response current in 2.2K resistor when 7 volt source is in operation. Previously, we have the current in the 2.2K when 5 volt source is in operation. Now, according to the superposition theorem statement, we have to see that the response in any element when all sources are in operation is equal to algebraic sum of responses when individual sources are in operation. Okay, individual sources are in operation while other sources are non-operative. So that means this I1, I2 plus I1. This I2 is a current. I2 is a current when 7 volt source is in operation. I1 is a current when 5 volt source is in operation. So the sum of these two must be equal to when all sources are in operation, the current. So that is given by already. We have 2.2. So the sum of I1 plus I2 also finally we have the same, we obtain same value 2.2 milliamperes. So therefore that is how superposition theorem is verified. So so that is about one problem. Next we see one more problem. Okay, so see that here for the given network, find the current in 47 ohm resistor using superposition theorem. So this circuit also has two voltage sources only, and the elements are 82, okay, 82 ohm, 100 ohm, 47 ohm. And question is, for this network, find the current in this 47 ohm resistor using superposition theorem. See that. So we know that first we have to consider all sources in operation, find the current. Find the response in the 47 ohm resistor. So this is the circuit when both sources are in operation, that is V1, V2. So let us say that current in that case is response in the 47 ohm resistor is capital I. So now find this current I. So for this circuit, how you can solve this circuit to find the current I. So I'm applying mesh analysis. I go for mesh analysis by taking two mesh currents here, I dash and I double dash. Okay, so I apply KVL in both. I write KVL equations for both meshes, and two equations I get, two unknowns which are I dash and I double dash. So after solving those equations, I get I dash and I double dash values. So from that, my I is given by I dash plus or minus I double dash. It depends on the directions of I dash and I double dash. It may be sum of those two or difference of those two. So that's why I have written I dash plus or minus I double dash. Okay. Now, when one source, consider first source V1. When voltage source V1 is acting alone. Okay. Only V1 is acting alone. Okay, that means only 15 volt source is connected. The elements are same given circuit. In the given circuit only the other voltage source 10 volt source is replaced with a short circuit. So then how to find the current in the 47? Say in that case current in the 47 is I1. So to find this current I1, okay, use our basic circuit solving, whatever the knowledge. I mean, it may be mesh analysis. Okay, I'm going with finding the total current. Okay, then using current division rule, I find the current in the 47, that is I1. Then I go with second source in operation, voltage source V2. In that case, the current in the 47 is I2. So then I find the current again here also, current from the supply, which is let us IT dash. I take it as IT dash. So by finding the total resistance here across the supply. So after finding this total current, I find the current I2 using again current division rule. So now after getting this I1 and I2 by superposition theorem, we see that I is equal to I1 plus I2. The sum of these two, when individual sources are in operation, the two currents are with respect to two voltage sources, we have the two responses I1 and I2. So the algebraic sum of these two responses equal to response when all sources are in operation. So I is a current when both sources are in operation. So I see that this is okay, verified. So that is how this problem is solved. Okay, that's all for now for this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.